Hey guys, this example that I'm going to go over with you was made by students from last year, Shreyas and Simon, so thank you guys. And this is 2018 number 4. So hopefully if you're watching this video, you've already tried the problem, but just to remind you, there is a function that's given called h, and it represents the height of a tree over time. Later on, they're going to define another function g, which also represents the height of the tree. But this one is defined by the diameter versus this one is defined by time. So in part A, it asks you to estimate h prime of 6. And though we don't have the equation for h, we can't actually find the instantaneous rate of change. So what we're going to do is we're going to find the average rate of change using this formula. And because we want to approximate this at 6, we're going to choose values closest to 6. So 5 and 7, and then plug them into average rate of change, find the slope, and we get 5/2. Now, the y values are in meters, and the x values, or the time values, are in years. So this would be 5/2 meters per year. And because this was a positive number, it means that the height of the tree is increasing or growing. So the height of the tree is growing at a rate of 5/2 meters per year at t equals 6 years. Remember that when you're explaining the meaning of something, you want to use MUT. Meaning, units, and time. And all three have to be included in your explanation. In part B, they want to know if there's at least one time where h prime of t equals 2. So hopefully that makes you think of using the mean value theorem because of the way the question is worded. Now what makes this problem a little weird is that if you try using 2 and 10, you may notice first off that those do not have equal signs, so we can't really use 2 and 10. But also if you did try using those, I don't think you'll get 2 if you find the average rate of change. And the mean value theorem says that h prime of c can equal 2 only if the average rate of change equals 2 for some values a and b. So basically what you want to do is take the values from your table and just try to find 2, where if you find the slope between them, you get 2. And so the first time that happens is if you choose 3 and 5 as your values. So here the students showed that if you chose 2 and 3, you would get 0.5, which didn't work. But if you choose 3 and 5 and you find the average rate of change, you do get 2. Now, once the average rate of change is equal to 2, you have to make sure you make a really clear statement as to why you're allowed to use the mean value theorem. So make sure you say it's because h is continuous on the closed interval from 3 to 5, and because h is differentiable on the open interval from 3 to 5. So by the mean value theorem and the fact that this average rate of change is 2, there must exist a value c in between 3 and 5 such that h prime of c equals 2. So again, what's weird is that you're not actually using 2 and 10. You're using values that you're just kind of guessing from the table until the average rate of change is actually 2. And this works because 3 and 5 are in this interval. In part C, you're supposed to use a trapezoid sum to approximate the average height of the tree. So one of the difficult parts of this is it is asking for average height. Remember that if you're finding the average value of something, you'll use this formula right here. So if we want the average height, it means that we want 1/10 minus 2 integral from 2 to 10 of h of t dt. So you're going to approximate h of t dt using trapezoids. This is the area of a trapezoid. The base values come from the y values of your table. The height value comes from the change in the x values. And you just add them all up and you get this. And then you're going to multiply this value by 1/8 because you're finding the average. So 10 minus 2, 1/8. And you get this. And so this would be in meters. And then in part D, like I mentioned earlier, they introduce a new function, g of x. And this also represents the height of the tree, but x is going to be the diameter of the tree and not the time. They tell you when the tree is 50 meters tall, the base is increasing at a rate of 0.03 meters per year. What is the rate of change of the height of the tree? So I translated all of this into kind of math. So I'm like, okay, the tree is 50 meters tall. That means G is 50. The base is increasing at a rate of 0.03 meters per year. This should say the base diameter. So that means dx dt is 0.03. What is the rate of change of the height of the tree? That means we want dg dt. So this sounds like a complete related rate to me. What that means is I want to find the derivative of this equation that they gave us with respect to time. But there is no time in it. So be careful when you find the derivative. The derivative of 100x is not just 100 anymore. It's 100 times dx dt, because the derivative of x is not going to be 1. It's because it's with respect to time. Now, when I find the derivative over here, I can just write dg dt. But on this side, I need to use the quotient rule because there's variables in the numerator and denominator. So this is what the derivative would look like with the quotient rule and with me finding the derivative with respect to time. So again, like low d high, the derivative of the top is 100 dx dt, like what I was explaining earlier, minus high, 100x, times d low. The derivative of the bottom is dx dt, because the derivative of 1 is 0. And then divide it by the bottom square. Now, after I wrote this formula out, I noticed that I knew dx dt because it was given here, but I don't know x. And that's like happening 3 times in my formula. So I do know that g is 50. So what I did is I plugged 50 back into the original function to find x, and I found that x was 1. So now I have x is 1, and I know dx dt is 0.03, and I plug that all into this equation, which is the work that I'm showing here, and I got 3/4. This would be in meters per year. Now the point breakdown, the first part was worth 2 points. You got 1 point for finding the right estimate of h prime of 6, and the second point was the interpretation, the meaning, with the units. In part B, that was also worth 2 points. You got a point for using the correct mean value theorem formula with 3 and 5 as your A and B values. And you got 1 point for writing the proper conclusion. So that would be like your full sentence with the continuity and differentiability and making it clear. In part C, you get 1 point for using the trapezoid sum, and then 1 point for the right overall answer. So that's including the 1/8. In part D, you got 2 points for showing dg dt, like I did just a minute ago with you guys, and you got 1 point for the answer. If for some reason you forgot the chain rule when you were finding the derivative, you could only earn 1 out of the 3 points, even if you got the right answer. Thank you.